This is perfect review for our quiz today. The quiz is going to go over force body diagrams, some of the forces equations, calculating some of those values, but also some of this stuff. So I want to make sure that we go over what we talked about last class in this diagram. And all I want you to do is label at least 5 things you can identify about what's happening in this diagram. And I want you to try to do it without your purple notes, because the purple notes is basically the answers. So really try to do it without your notes to see how much you can remember, and then we'll go over all of the different things you've come up with and answer any questions that you have. I wanted you to do this without your purple worksheet, and let's try to see, there's definitely more than 5, but let's try to come up with as many as we can. So I want some new volunteers. Max.
So on that peak, you could label it as max static.
Max static. Very good. This peak right here is our max static friction. I wouldn't say just static friction, because technically all of this is static friction. Remember, static friction matches your applied force. So max is the key word. Very good. Any other volunteers new? Bennett?
Is the box constant velocity?
So the box here, this flat surface represents constant velocity. Let me have Bella. It's what? This is the transition from the peak down.
Or no.
Oh, this peak down. This is the transition into kinetic friction. Writing sideways is harder than it looks. Thank you. All right. Let's go ahead and no new? Okay, I'll go with Leo first.
I've got a question.
Question.
For the max static friction, do you want us to drop a link at the top?
You don't have to. I do want you to indicate specifically what part if I tell you to show it on the graph. But it just depends on the question.
Then, for the slope up, you can say it's static before friction.
This one is static friction. Before it starts moving. So I'm going to say at rest. Good. Tamar.
This mean.
You want to draw a line?
Number mean. You still say there's a mean.
A mean value here. So did you get that mean value?
There. Oh, it's right there.
It's right there.
6.0.
Oh wait,
So 6.0 is a value. They say it's the mean, but the mean means average. So it's not specific enough for me to know what you're talking about. What exactly is this 6.0 representing? Can someone tell me, Leah? This is the kinetic friction. Good. And it's the kinetic friction when we have constant velocity. All right, anything else to add, Leah? Above constant velocity, this one is also kinetic. So kinetic also runs from this point out. So all of that is kinetic friction. Leah?
Accelerating from the down.
Very good. You've got an acceleration here. It's when it starts at rest and then increases speed. So there is an acceleration. So acceleration kinetic, constant speed kinetic. Good distinction. Is there anything else we can add to this? I can think of one thing. Anyone? Can you think of one thing, Bennett?
I don't be really We can label that.
You can label the axis here. I'm not going to have that tested, but we've got frictional force in newtons. I'm going to put in parentheses, time in seconds. Tomer?
Not the value, but estimate what the max static friction is.
We can estimate the max static friction. So someone give me an estimate as best as you can. Tomer, what do you think?
Yeah, I would say 7.
7 newtons. I'll take 7. Anyone have something, come up with an estimate that was different than 7? Anything around maybe 7 point, I would say anything between 7 and 7.5 probably works, right? So an estimate for that value, max, is perfect. And then I wanted to highlight one last thing. Between static and kinetic friction, what is the consistency about those two values? What do we know about static, at least max static friction versus kinetic friction? Yeah. Always. Max static is greater than kinetic. That is the maximum frictional value that we can get when we're going from rest into motion. And kinetic friction, no matter how hard you pull it, will never exceed that. Any questions? Okay, so this quiz is based on worksheet 2, which was force body diagrams, calculating the forces, and worksheet 3, which had adding some of those values. Remember, I want to see work. So I want to see that you're using the sum of the forces equations. You've got your equations here for the force of gravity. You've got the sum of the forces symbol right here. There is an equation for friction, but are we ever going to use the equation for friction in this class? No. All I want you to know from that equation is that mu is the roughness, normal is the force the floor is pushing up, and those are the only 2 factors that affect the frictional force. Any last minute questions before we start our quiz? This quiz is going to be force body diagrams, and then it's going to have you do some of the forces equations and give me some number values. So worksheet 2 and worksheet 3, and then it's going to be on this stuff that we just talked about. Question maps. But the first thing I'm going to do, and I'll walk you through this step by step, is on your computer. Every single computer should have this already downloaded. The benefits of being my last class is that my first few periods do all of this grunt work for you. So it should be on your desktop. It's called the fan cart lab. Everyone's going to get a fan cart. So materials managers, you're going to grab one of these. You're going to grab a scale, and you are going to grab a ramp. Now, not all of my desks have a place where you can kind of hit a wall. And so if we can't do that, we'll use alternative methods. So the first thing you're going to do to set this up, and I'll walk you through this just for the first step together, but we need to connect our cart through Bluetooth. So hardware setup, you want to turn on, there's a button to turn on your cart. You're going to see the blinking lights. And then you're going to see not just one, but all 8 carts show up on your computer. So you want to look for the number right next to the Bluetooth symbol and connect to the correct smart cart. Uh-oh, where'd it go? There it is. Okay. Once it's connected, we're going to plot 2 graphs. One is acceleration and one is force. So if you look on your force sensor, if you look on your worksheet, we've got something called thrust. Thrust is the force that wind uses to push an object back. So if you look at this smart cart, I'm just going to turn it on. when I turn it on, the wind is pushed forward by the fan, but then the thrust pushes the fan backward. So you're going to hit multiple ranges of thrust. So this is low, medium, and this is high. Okay, what your graph is going to look like and what you are going to evaluate. First of all, let me show you your worksheet. Let me grab a new one. If your computer's not working, these Mac Minis are on freeze mode, so every time it shuts down, it disconnects. You just have to disconnect your mouse or disconnect your keyboard and reconnect it, and it should work again. Again, technical difficulties. But this is your worksheet. Let's go through the first few together. Thrust is 0. So your force, if I have the wind pushing backward, that's our thrust, with 0%, what do you think your force is going to be? Nada, 0. 0. Everything that you fill in here, we're going to transfer down here. So if I have a force of 0 newtons pushing my fan backward, what would my acceleration then be? 0. The lab's not that easy. So we got the first part. Let's go ahead and calculate our force. So this is how you're going to calculate your force. First thing you're going to do, let me get my graph back up there. We want to make sure everything is calibrated. So I'm gonna get a volunteer. Can I get a volunteer just to help me with my fan? Timmy, is that a volunteer or is that a stretch?
Yeah.
Thank you. All I want you to do, Timmy, is make sure that that cart does not move. So you're just gonna hold it, keep it still. Also, these carts are nearly frictionless. So if you let it go and it rolls off your table, that's like $100 or more worth of materials. So please make sure that you don't drop any of my materials. Okay, first thing I'm going to do is calibrate. So there's a stopper at the end of my cart. Timmy's not going to touch that. He's just going to make sure that when I turn the cart on, everything is at 0. So I want you to notice something. Thrust has number values here. I can increase it and decrease it. That's this smart fan option. We're going to start at 50. And then I'm going to turn it on, but Timmy's going to make sure it doesn't move. So I want to see that my acceleration is 0 and my force is 0. Now here my force isn't being read, and this happened a lot in my last class. So if that happens, I'm going to have to reconnect it. And call me over if this is what happens in your group. 0 sensor means that if it's not calibrated, I'm going to calibrate it. And then I'm going to report. There we go. I have 0 force, 0 acceleration. Okay, Timmy, I want you to put your hand on the end of the stopper, but don't let my cart move. So this right here. So Timmy's going to hold it still so that it doesn't move. And now we have the force of the thrust. It looks like it's still 0. So let me stop it. And then if I stretch my graph up, it still looks like 0. Let's try it a different way. Okay, so Timmy, you're going to hold it. You're going to take your hand off the stopper. Just put it, just hold it at the top like you were before. And then you're going to let it run. So let's let it run. And then let go. So this is impact. If I stop it, this is my force. This is the force when the fan is butting up against the wall, and it is a constant force. Let's give Timmy 2 claps. Okay, so here I am going to Find the mean, the same way we found the mean for our friction of a shoe lab. This is the highlighter symbol. And you highlight just this part of your graph that shows that it's pretty constant. And then you're going to click the highlight and you're going to see the summation symbol. Mean is already checked. Problem is we can't see it, so we uncheck it and recheck it. Go ahead and write this down. 50% thrust gives you 0.106 force. So let's move here. 50% thrust, 0.106 force. Is that what I told you?
Yeah.
Okay, good. So I'm going to transfer it down. I'm going to do this part for you just because my other groups struggled capturing data. So then the next step we're going to do is find the acceleration. The acceleration on our graph, if you look at this, it looks like nothing much happens until this spike. But if I want to zoom in, I'm just going to drag it down to the center and I go to my scale. If I move my scale up, you're going to see that it actually changes from here to here. I can increase my scale this way, and you're going to notice that change. So what happens is my part is at rest. That's all of this part. It's just sitting at rest. There's a lot of kind of bouncing around. But at some point, it starts accelerating from 0 up, and then the acceleration is constant until it smashes into the wall. That constant velocity is what we want. This section right here. And you can increase it or decrease it depending on how constant it is. Once it starts fluctuating, you want to decrease it out of that point. But we're going to hit mean again. Unclick it, re-click it. This is our acceleration. So you're going to put that in your chart. 0.195. Okay. My tech managers, you're going to do this with different types of thrust. So here I had 0.195 acceleration. Your thrust has to be anything greater than 50. It maxes out at 100. So you can do 75 and 85 or 70 and 90. It doesn't matter to me what you choose, but I want to make sure you don't go any lower than that. Again, how you change things for your fan is smart fan right here. So you increase your thrust to 75 and your number value should do what? If I increase my thrust, what should happen to my force? What should happen to my acceleration? If your patterns are not consistent, we've got some technical difficulties and call me over. Okay, that's a lot of information for you to absorb at once. So Miss Lee, let me pull out her slideshow. If you don't know what to do, I want my tech managers to have this open in the background. It is directions, slideshow directions on how to conduct this lab, especially containing the software. So once you get to the software portion, all of these steps are really important. It tells you to calibrate. It tells you to open the FanCart lab, not any other simulation. And then it tells you how to analyze your graphs too. So we get to collecting data down here, and it shows you how to highlight and find the mean. Okay? So make sure my tech managers have that open. Everyone paid attention, so try to provide your tech manager help when they need it. And then also, I have some notes on the board because my last period didn't have any of this technology working for them. But if you need me, come and see me for help. Once you've gathered your force and acceleration data, then you can start pulling out your end plot information and the link to that is also on Canvas. So if you want to start graphing, then you're going to click on the M plot on Canvas here.